So in the next section, we're going to talk about measuring the strength of the association with a number, and that number is actually what we refer to as the correlation. Okay, so the correlation is always denoted by the letter R. If you remember back when we were talking about means and standard deviation, we had X bar and S to represent mean and standard deviation, and now we have this R that measures how linear the how linear the association is between two variables. Okay, R is always a number between -1 and 1, and since we're not actually ever going to compute it using our calculator or the formula, we're going to let StatCrunch do it, then it just ends up becoming between -1 and 1. Okay, and the closer the R value is to 1, and that's the more strongly positive the association is. If as R is close to -1, then there's a strong negative association, and close to 0, there's a weak or no linear association. So the sign on R actually tells you the direction of the association. So if R is negative, it's a negative association. If R is positive, it's a positive association. And again, just remember that the closer you are to 0 means you have no linear association. As you move away from 0 in either direction, towards -1 or towards 1, your association between the two variables becomes stronger. Okay, so here's some examples where we have a positive correlation, and you notice all of these examples have a stronger association also. Okay, in order to have a correlation of 1, your points have to all fall exactly on a line. So if you look here, if I draw a line, it would actually pass through every single one of these points. Okay, here we have a correlation that's very close to 1, and you notice that the points are all very close to each other. Okay, but again, they're not all exactly on a line, so the correlation is not exactly 1. As my correlation is getting closer to 0, my points are getting more spread out. So here's your correlation of 0.72, and here's your correlation of 0.48. And notice they're starting to get a lot more scattered by the time you get down to that correlation of 0.48. Okay, these all have a weak or no correlation, and you notice that their correlation, the value of the correlation is very close to 0. And if you notice here, you can't really put a line through any of these scatter plots. This one you can tell that it's somewhat negative, right? You notice it's getting closer to -1 than the other two are. Okay, and again, here's negative correlations, and you notice as the correlation gets closer to -1 that your association gets closer to -1. I'm sorry, your association gets closer to a straight line. So again, the only way you can have a correlation of exactly -1 if all your points fall exactly on a line like they do in this case. So here's your correlation is -0.9. The points are fairly close to each other, but again, they have that negative association. Okay, so when you're interpreting correlation, it kind of goes along with the same idea as when we did association, is you want to use the words tend or predict. Don't try to say that one thing causes the other, such as it does not mean that people who buy swimsuits are causing potential ski jacket buyers to not buy. Okay, probably what's happening is as you buy swimsuits, it's summertime, so of course you're not going to buy as many ski jackets. So there's this what we call lurking variable between swimsuits and ski jackets as actually the temperature. So what the temperature is outside determines if you want a swimsuit or a ski jacket. Okay. So to use StatCrunch to find R, we're going to enter our data in. I'll go over to StatCrunch in a second. Okay, and then we're going to go to in the Stat menu to Regression and choose Simple Linear, select our variables, and then do Compute. So here's your screenshots, and again, I'll go over there and actually do it. Oops. Okay, so I'm going to load the weather data. So first I'm going to go to Data, and we're going to load from Shared Data Sets. And if you just type in Burns Beth here, okay, all of the data sets that I have shared will show up. And if you scroll down, you'll see the one for Bowling Green weather. Okay. Okay, so what we have is for each year, we have the lowest temperature, the highest temperature, the warmest minimum, the coldest maximum. And you'd think that some of these would have some type of an association. Okay, so we're going to go to Stat. Okay, choose Regression and then Simple Linear. Okay, so what I want to see is if there's a correlation between the lowest temperature These are all for January. The lowest temperature in January and the highest temperature in January. Okay, so I'm going to choose highest temperature and lowest temperature, and then all I need to do is press compute, right? And then it gives me the correlation. It's this number right up here. Okay, so the correlation in this problem is about 0.479 if I round to 3 places. Okay, so it's not it's not a very strong association. If you click the little arrow down here, you actually can see the points with the line, and you see they're pretty scattered around the line. Okay, so that's how you would find the correlation if you're using StatCrunch. Okay, now what happens if I switch my X and my Y around for the correlation? Okay, well, let's come back over here. Oops. Okay, let's do that same thing again. Okay, so we're going to choose stat and then regression and simple linear. Okay, on this one I chose highest temperature for my X and lowest temperature for my Y. So I'm just going to switch them and do lowest temperature for X and highest temperature for Y. Okay, tell it to compute. Let's scoot this one over. And if I go back, right, you notice here my correlation was that 0.479, and here I have that exact same number for the correlation. Okay, so correlation does not depend on which variable is X and which is Y. Because if you think about what the graphs will look like, okay, so here's my 2 graphs. All I kind of did was turn my head sideways. It doesn't matter which is on the X or Y. The relationships of the points to each other will still be the same. Okay, so that's why the correlation still has to be the same regardless of which one you call X and which you call Y. Okay. Now, what happens if I multiply all of my X's or Y's by a constant? It's also not going to change R. Adding the same constant doesn't change R. X's doesn't change R. Okay. Or do the example, we're going to change units. We're going to actually take our temperatures that are in degrees Fahrenheit, convert them to degrees Celsius, and see that I still have the same R. And also, when you give the value of R, it has no units attached to it. Okay. Like in the example I have, our temperatures are all in degrees Fahrenheit, and you should actually say things like -15 degrees Fahrenheit. Okay, or if you measure yourself, you should attach inches to it. But R is unitless. When you give the unit, when you say what R is, you just say it's like -0.49. You don't attach any units to it. So let's come back over here. Okay, and I'm going to make a column, and we're going to take the highest temperatures, and we're going to convert them to Celsius instead of Fahrenheit. Okay, so first thing we got to figure out how to convert Fahrenheit to Celsius. Okay, so if I know Fahrenheit and I want to convert it to Celsius, there's my formula, right? So Celsius temperature is 5/9 the Fahrenheit temperature minus 32. Okay, so if I come back over here, okay, I'm going to compute expression. Okay, again, we're going to build it, and we want to take 5 divided by 9 times, and then I need my parentheses. Okay, and we're going to do highest temperature, add it, and then minus 32. Okay, so that'll convert the column for highest temperatures. We're going to convert them from Fahrenheit to Celsius. Click OK, and I'm just going to label this column so I know what it is. Highest temperature, oops. And I'm going to put it C so we know that's in Celsius. Okay, so then it created my new column. Okay, so now I want to make a scatter plot with the highest temperature in Celsius and lowest temperature in Fahrenheit. Okay, so again, go to Stat, Regression, Simple Linear. Okay, so my X variable is highest temperature Celsius. I'm going to choose it. My Y I'm going to leave at lowest temperature. Okay, and then just tell it to compute. Okay, and let me go back here on this one. And you notice I still have the exact same correlation. Okay, if you look at the difference in their scatter plots, it makes sense you'd have the same correlation because the only thing that changed from the scatter plot where they were both in Fahrenheit to the one where I used Celsius for the highest temperature is how the x-axis here is labeled. Okay, that's the only thing I changed. Okay, so I still actually have the exact same thing. Okay, so if you remember, 32 degrees is about the is 0 degrees Celsius. So here's 32 degrees Fahrenheit, it's about 0 degrees Celsius, and you can see that point right there on my graph. Okay, so it stayed in relationship on the x-axis the same. So that's why if you change units, it doesn't change anything. Same thing back when we were talking here, if you multiply or add the same number to all your x's and y's, it's not going to change the correlation either. All it does is change the x and y scale. Okay. Okay, sometimes you might have a correlation, but you got to actually still look at the scatter plot to tell whether or not it's useless. Okay, so we'll only use linear correlation to interpret the data when there's a linear relationship. And even then, even if it's not linear, even if it is linear, sometimes R is still not useful. Okay, so if you look at this example, R is actually useful here. Okay, all four of these graphs, by the way, have a correlation of 0.817. Okay. Here, this is actually fairly close to 1, so you'd think the graph should be fairly linear. You notice everything lines up on the 8, but you come over here, you have this 1 point. Okay, so in this case, R is not useful because of that outlier. Okay, here, we almost have a perfectly straight line except for the 1 point. Okay, but if you're going to talk about it, you should say, well, all the points fall in a straight line except for this point. So it's useful, but you should actually make a note of that outlier. Okay. Again, here you notice you have this nice, pretty strong positive association up until you get to about 10. Okay, and then you have these few dots over here on the other side. So again, this graph is not linear, so even though the correlation is fairly close to 1, it's not useful to actually say what to give a correlation because your graph, the form of it is not linear. Okay, so correlation only measures how linear their graph is. Okay, so if your graph is not linear, you shouldn't give a correlation, even if the correlation is fairly close to either +1 or -1. Okay, so that's it for correlation, and then we'll start talking about putting lines through these points in the next section.